next section, we're going to go over ellipses. So the definition of an ellipse is a collection of all points in the plane, the sum of whose distances from two fixed points called the foci are constant. So we have two options. One option is my ellipse is longer horizontally or it's longer vertically. So this center point is exactly the center, and this point in the middle is also called the center. So this center in general we call it HK. So this center, whether it opens longer horizontally or vertically, the center is still HK. And if I was following that definition, we're going to need foci as well. So the foci are actually going to be aligned with that center. So the foci are going to be aligned with that center. If the longer side is horizontal, the foci are going to be aligned horizontally. If the ellipse is longer vertically, then the foci are going to be aligned vertically. So following that definition, an ellipse is a collection of all points in the plane, the sum of whose distances from two fixed points, these two, called the foci, are the same, are constant. So for example, if I go draw a line from here to this point on the ellipse all the way down here, the sum of these two lengths that I would draw would be equal to the sum of any other two lengths that I would draw. So if I start at this focus and I end at this point up here, and then I go down to this point, that length, that total length is going to be equal to the total length for the first point that I chose. Now if I chose even this point over here, the distance or the length, the total length between this focus, that point, to this other focus is equal to the length between this focus to the second point that I came up with to this focus, and it's also equal to the distance between this focus to this point to this focus again. So all of those are equal distance. So again, let's go ahead and label our foci. So this is focus number 1, and this is focus number 2. And if we're going vertically, I'm going to call this one focus 1, and this one is going to be focus 2. We also have vertices on the ellipses. So those vertices are going to be aligned with those foci, also with the center. So I'm going to call this vertex 1, and I'm going to call this one vertex 2. And we're going to align the vertices for the ellipse that has a longer side opening up or vertically. So this is going to be vertex 1, and this one's going to be vertex 2. So we also have something called a major axis. The major axis is going to be this line that goes through the center, the foci, and the vertices. So this major axis, if it opens horizontally, if it's longer horizontally, is also going to be horizontal. The major axis is going to be vertical if the longer side is vertical for the ellipse. So this again is called the major axis. And for this one is the major axis. So we also have points on the opposite side of the center vertically. So vertically, that would be the minor axis. So this line going up and down vertically perpendicular to the major axis is called the minor axis. And the points on the minor axis would be these two right here. We're going to give them actual names in a second. And then for the other one, the one that opens up and down, so the one that's longer vertically, the minor axis is going to be the horizontal one. Again, it goes perpendicular to the major axis. So this one's the minor axis. And then we have 2 points on the ellipse that are on the minor axis. So in order to find all of these points, let's first start with the focus. So the distance between the center and the focus is equal to c. If this distance is equal to c, that means I'm going c units to the right, which means I would end up changing the h. By c, I would end up adding a c to the h. So h plus c, comma k. Again, if the distance between the center and the focus is equal to c, and now I'm going to the left, Now I'm going to subtract a c from this x value. So the only value that's changing if I go left or if I go right is the x value. So now this one becomes h minus c comma k. The y value stays the same. So that's for the focus for these two. And for the foci for the ellipse that opens up and down longer, or that it's longer up and down, it's going to be c units away, but now it's going up, and it's going down. So if I'm going up by c units, the k is the one that's going to change. So the h is going to stay the same, and it's going to now be k plus c. And if I go down for focus number 2, it's going to be going down by c. So it's h comma k minus c. And then for these other points, for the vertices, so these vertices are a distance of a from the center. So let's go ahead and write down what c and a are. C is a distance from the origin, or from the center. It's not always the origin. So from the center to the focus. It doesn't matter which one it is. And a is the distance from the center to the vertex, so the vertices. Distance from the center to this vertex is a, distance from this center to this vertex is equal to a. Same thing with the distance from this center to this vertex and the distance from this center to that vertex. So if I'm going a units to the right, now this point for the vertex is going to be h plus a comma k. The x value is the one that's going to change. So from h, we go a units to the right, it becomes h plus a. Y value is still the same. So it's still the same y value. Also for the point on the left, but now it's going to the left by a units. So it's going to be h minus a comma k. And now for these vertices, it's going up by a units away from the center, and it's going down by a units away from the center. So now it's going to change the k value. It's going to change the y value. So the x value, which is h, is going to be the same. So h, and I'm going a units away, going up from the center. So now it's going to be k plus a. So if I'm going a units down, then that means that the y value is changing. So the x value stays the same, it's h, and the y value, it used to be k, but I'm going down by a unit, so now it's k minus a. So again, the distance from the center to the focus is c, distance from the center to the vertex is equal to a. So what about the minor axis? So the distance between the center and the minor axis is actually equal to b. So b is the distance from the center to a point on the minor axis. So we don't actually have a name for this point, but we can give it a label. So to a point on the minor axis. And that means that if the distance between here and here is equal to b, that means that we're going b up. So if we're going b up, the one that's going to change now is going to be the k. So it's the y value. The h is going to be the same, the x value is going to be the same. The y value is now going to be k plus, we're going b units away, so it's going to be k plus b. And if we are going down by b units, that means at this point, this other point on the minor axis is going to be h, k minus b. So we're going down by b units. And now this point is on the right side of the center. That means that we're going to the right by b units. If we're going to the right, the value that changes now is going to be the x value. So now it's going to be h plus b, and then the y value is going to be the same, which is k. The other point on the minor axis, we're going b units away, but now to the left. So the x value is changing, and we're going to make it h minus b, and the y value is the same, so that's still k. One more really important thing about these ellipses is their equations. So for this one, it's going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So this a squared always goes into the variable in terms, depending on the major axis. So if the major axis is parallel to the x-axis, then a squared is going to go under the x. So if the major axis is parallel to the y-axis, then the a squared is going to go under the y's. So the equation for this one is going to become x minus h squared over b squared plus y minus k squared over a squared. Again, the a squared goes under the variable that's parallel to the major axis. So this is equal to 1 also. So we have to make sure that it's equal to 1 and that there's a plus sign in between these two. So I'm going to email you guys this other cleaner version of the ellipses, of the pictures for the ellipses, the one that opens left and right, so longer horizontally, and the one that opens longer vertically. So on this one, I also specified that a has to be bigger than b, which is bigger than 0, so this denominator cannot be equal to 0 for either one of these two.